Okay, today's notes are on page 8, and you're going to do volume of pyramids and volume of cones. So for your periods, remember that they come to a point up above. So in prisms and cylinders, they had two bases that were parallel to each other, connected by their height. In a pyramid, all of your bases float up, or triangle bases, float up to a point up above, and they still have a height, but that height must drop down to be perpendicular to the base. So again, those nodes are right here. But big B is the area of the base, and H is going to be your height. Remember, your height must connect, must be perpendicular to your base. So just make sure you remember that. My base shape here is going to be a rectangle. So if I want to define big B separately, I'm going to take base times height, which is just 10 times 11. So my big B is 110. Okay, now to go to volume, we have to do a couple things. We need a 1/3, that's new, for pyramids. And then again, I need that height. So that height must drop down, it must be perpendicular to the base. So I know it's perpendicular to the base, is my right angle right there. So my overall height is 16. So the area of your base, you take it 16. Make sure you remember that 1/3. So our volume here is going to be 586.66 feet, meaning 4.7 inches. Okay, so let's look at let's look at number 3. So on here, my base shape is going to be a square. So I can start by finding the area of my square. And that area is just going to be base times height. 14 times 14, which is 96. Okay, now for our height of our overall prism, normally the height of your overall prism, I understand that on roof, it should go from the top perpendicular to the center of your base. Well, this segment is not dropping perpendicular to the center of the base, it's dropping perpendicular to the sides. That's not my height. That's actually called your slant. So I need to find this segment right here in yellow in order to help me solve this right triangle. So this is the right triangle I actually need. This is the actual height. So I have the hypotenuse, and I have this yellow segment. It's halfway through that base. So halfway 14 is going to be 7, and I can solve for my height. So again, 7 squared plus 8 squared plus 25 squared. So again, there should always be fraction problems when it comes to your boundary pyramid. So our height here is going to be 24. So taking it to volume, don't forget your 1/3 for the pyramids. Area of the base times my height is found, 24. So my volume there should be 1,568. Let's look at number 5. Oh no, 6. My base shape on number 6 is a triangle, a triangular pyramid, and specifically it is an equilateral triangle, which means I don't have any right angles in it. So I can't find my area of the base right now. The area of the base would be 1/2 base times height, but remember those need to be perpendicular. I have nothing perpendicular. So if I draw this equilateral triangle, I want the height. I'm going to be dealing with 5 here, 10, and then trying to find the height. Again, because I'm cutting that triangle in half to make the right triangle out of the equilateral. So 5 squared plus h squared equals 10 squared, always fraction. Squared minus 5 squared, and then overall height of 8.66. Again, this is where rounding can start taking effect. If you use 8.7, your answer is going to be a little bit minus 1/3. Go back to the original base. A whole triangle has a base of 10, and that's the base you actually want to use as perpendicular to that height that we have. So that is going to be go for volume, you need your area on the base, and that height, and the height they gave me, yes, it is perpendicular to the center. So I can run with my volume. Volume is going to equal bigger 1/3, big B, 4313, times your height, which is 16, for a volume of 230. Okay, let's look at cones. So cones have a very similar formula to cylinders, except for again, it's going to have my 1/3. 1/3 pi radius squared times your height. Anything that comes to a point, you just need to remember that 1/3. So basically, you're going to forget, try to remember it. So let's look at number B. On number B, I want to find the volume of this. And again, I need my radius. I don't have it right now. So your radius is equal to half your diameter. So in this case, my radius is 2.5. So I'm going to do volume is 1/3 pi 2.5 squared, and that height is 8. Again, because of it dropping perpendicular to the base, specifically the center. So my volume there is going to be equal to 136 inches. On number 9, I don't have my radius again. My radius is half my diameter, so 13.5. And I also don't have my height because my height needs to drop down from the center to the center in order to make that right angle. And I don't have that. But I do have a right triangle that is being formed. So again, I have that slant height, I have that diagonal height, but I need the actual perpendicular straight down height. So really want to run the Pythagorean theorem. We just found our radius to be 13.5. We're trying to find our height. So go ahead and pause the video and practice finding the height so you can the Pythagorean theorem here of this figure. Okay, so for your height, and you should have gotten 18. So remember, it's a subtraction problem. So going to volume, 1/3 pi radius squared times your height. So our overall volume should be 3,435.33 liters. Okay, on number 10, it's a word problem. So remember, what I have to do is identify my shape. So it says a cone has a volume of this. So I want to write the volume formula of the cone and fill in the pieces as I go. So it tells me my volume is 1,300. 1/3 is never going to change. 5 is never change. It tells me I have a height of 8 centimeters. And it asks me to find the radius. Okay, so breaking this down, I would divide by 1/3. I would then divide by 2,127. I would then divide by 5. Divide by 8. And then 6.3. And then lastly, we take square. We get 12.5 for that radius, and the unit is centimeters. So you might be like, why don't you just divide all those separately? You could do it all at the same time. So just keep that in mind. I just wanted to show you broken down here, but you could do it all at the same time. Alright. Caitlin must build a sandcastle in the form of a square pyramid, or as shown to the left. So first, all I want you to do is I want you to find the volume of that square here. So big B, B base times height, your square. Volume would be 1/3 big B times the height of that. So go ahead and pause the video and do that. Okay, so looking at this, I would take 25 times 25, would be 645 for 5 days. I would use that and I'd do 1/3, 645 times 18, because that's the overall height of my pyramid, it's dropping down to the center of my base. And I would get 3,740. Now, on this one, they actually asked you, they said she bought 3 bags of sand, each bag containing 1,200 inches cubed of sand. Will she have enough to build the castle? Well, I can figure out how much she has. She has 3 bags with 1,200 in it. So she has 3,600 inches cubed of sand. So will she have enough? No. She will. Okay, let's look at row 11. Cylinder to the left contains 2 congruent hollow points. If the cylinder's height is 20 inches and its diameter is 14 inches, find the volume of the solid. So the first thing I have to do is find the volume of your cylinder. This is from the other day. The formula is pi a squared times height. Okay? Keep in mind to find your radius, so go ahead and pause the video and find that radius. And the overall volume. Okay? Okay, so our volume would be pi times radius, which is actually going to be 14 divided by 2 to give us 7 squared times our height, which is 20. And that gets us a volume for our cylinder of 3,078.76. So now we have to find the volume of our cone. And that formula is 1/3 pi radius squared times height. Now here's the problem. Our radius can be the same as before, but our height is going to have to be different. So there is 2 cones in here. Which means if our overall height is 20, our height for both cones is going to have to be half that. So it's going to have to be 10. Now again, once you find the volume of that cone, there are 2 of them. So you need to make sure that once you find the single volume, you are timing it by 2 because there's 2 cones. So go ahead and pause the video and do that on your own. Okay, so we should be doing 2 times our 1/3 pi. Our radius is still 7 squared, but our height is 10. For the volume of the cone to be 1,026.25. Now, that's not what they were asking for. It said it contains 2 hollow cones. That means that the cones are empty, which means we are going to want to subtract our cones. So I'm going to subtract for a grand total volume of 2,052.51 inches. All right, make sure you bring any questions you may have to class tomorrow.